In the last episode, we discussed the collision theory, the three factors for a chemical reaction to take place. The first factor is the molecular collision. It states that molecules need to collide in order to react. The second factor is called the activation energy. It states that not all collisions will result in a chemical reaction. They need to collide really hard so that they can overcome the minimum energy required for a reaction to take place. That minimum energy required for a reaction to take place is called activation energy. The third factor is the collision orientation. They need to collide at the correct spot. Today, we discuss factors that affecting the chemical reaction rate. If we understand what's going on in the collision theory that we learned in the last episode, all today's content will come really naturally. It's very easy to understand. So first, what is a chemical reaction rate? It is the rate at which the reactions are consumed or the products are produced. So there are four factors affecting the chemical reaction rate. Number one, the physical nature of the reactants. Number two, reactant concentrations. Number three, reaction temperature. Number four, the presence of catalysts. The first one, physical nature of reactants. Talking about physical nature, there are two aspects that could affect the reaction rate. Number one is the physical state of each substance. Is it a solid? Is it a liquid? Is it a gas? Number two is the particle size. So looking at the physical states of each reactant, when all the reactants are all in the same physical states, all reactants are solids or all reactants are liquids or gases, all right? In this case, gases react the fastest, followed by liquids, followed by solids. Well, as you can see, the particles in solid state, they do not have movement basically. They are staying in the fixed position. The chance for them to collide is very, very small. Only the particles on the surface has the opportunity to get into contact with each other. And as we know, in solid state, the particles has the minimum kinetic energy compared with liquid or gases. Therefore, the chance for the solid particles to react is way less than between liquid particles or between gas particles. Out of the three states, gas particles has the most freedom to move. Therefore, they have the most opportunities to collide with each other. So in general, gases react the fastest, followed by the liquids. Solids are the slowest. Talking about the particle size is more relevant to the solid state reactant. If a reactant is a solid, then reaction rate increases as the subdivision of the solid increases. So fine particles react faster than the big chunks. Well, again, it's also easy to understand. For solid state particles, only the particles on the surface of the solid state has an opportunity to collide with other reactants. Therefore, the finer the particle, the smaller the particle, the greater the surface area. The greater the surface area, the more molecules or particles will be on the surface of the solid. So when particle size of a solid is extremely small, reaction rates can be so fast that an explosion may happen. Okay? May happen. And in one reality situation, is that the coal mining business, the people working in the underground coal mining environment, they need to be very careful about the spontaneous ignition of the coal dust because the coal dust has huge surface area. If reaction occurs, the reaction is going to be spontaneous and explosion will happen. So that's one thing that threatens the people working underground in the coal mining business. The second factor, reactant concentrations. Higher concentration, faster reaction. Why is that? The higher the concentration, the more likely the substance will collide with other reactants. So very straightforward. There are more molecules of that reactant present in the reaction mixture. When the concentration is higher, there are more molecules of that reactant present in the reaction mixture. Therefore, collisions between that reactant and other reactant particles are more likely. So, more collisions, faster reaction. Temperature, higher temperature, faster reaction. When temperature is higher, particles move faster. Particles have higher kinetic energy. That has two consequences. Number one, when they move faster, they collide more often. So more collisions, faster reaction. That's number one. Number two, when temperature is higher, particles move faster. They have higher kinetic energy. So more of those collisions will be able to overcome the activation energy. So both factors result in the higher reaction rate. Higher temperature, faster reaction. Presence of catalyst. A catalyst is a substance that increases a chemical reaction rate, but itself is not consumed in the chemical reaction. It looks like it is not involved in the chemical reaction, but actually it is. We do not go through the details of the mechanism of how a catalyst works, but we do want to know the way through what method a catalyst will make a reaction faster if itself is not consumed. So what is going on? Well, that is because when a catalyst is involved, the catalyst will work with the reactants so that they can provide an alternative reaction pathways. The new reaction pathway has a lower activation energy than the one without the catalyst. When the activation energy is lower, more collisions will be able to overcome that activation energy. Therefore, faster reaction. Enzymes are the catalyst in the human body. This figure provides a very good explanation of how a catalyst works. So the dotted line represents the reaction pathway without a catalyst. That is the activation energy required when there's no catalyst. Once a catalyst is introduced into the system, a different reaction pathway appeared. Now it is represented by the solid line here. This pathway has a lower activation energy. When the activation energy is lower, more collisions will be able to overcome that energy. Therefore, faster reaction. We are basically done with today's content. Let's have a quick review of the four factors that affect reaction rate. Number one, physical nature of the reactants. There are two aspects under this item. The first one is the physical states of the reactants. Are they liquids, solids, or gases? when the reactants are all in the same physical state, gases in general, gases react faster than liquids, liquids react faster than solids. The second aspect of this item is that the surface area if the reactant is a solid. So for a solid reactant, the greater the surface area, the faster the reaction. When the surface area is greater, there are more molecules on the surface. Only the surface molecules has an opportunity to collide with other reactant particles. So that's physical nature. The second one is the reactant concentration. The higher the concentration, the faster the reaction, because the higher the concentration, the more collisions will happen between that reactant and other reactants. Number 3, reaction temperature. The higher the temperature, the faster the reaction, because when temperature is higher, it causes, number 1, more collisions. Number 2, more collisions are able to overcome the activation energy. Both factors make the reaction rate faster. Number 4 is the presence of a catalyst. Catalyst increase the reaction rate by providing an alternative reaction pathway that has a lower activation energy. In other words, catalyst catalyze a chemical reaction by lowering the activation energy of the reaction. A catalyst catalyzes a chemical reaction by lowering the activation energy of the reaction. See you next time.